Welcome to all of you B.Sc 3 physics students. Now in this academic year in semester 5th, I am going to teach you physics paper 10. Title is Solid State Physics. Myself is Professor Dr. Sau L.K. Bagal. So I am going to start topic first. The title is Crystallography. Now under this title, I will teach you introductory part of the crystallography, then brevicelles and lattices and unit cells. Now this image shows just the schematic of the crystallography. Now what is the matter? Any substance which has mass and which occupies space is called as the matter. Now all physical objects are composed of matter. Matter is classified into three types. One is solid, second liquid, third gas. And nowadays the fourth state of the matter is the plasma. Now what is the solids? Objects with definite size and shape are known as solids. Incompressible, rigid, mechanically strong are the solids. In solids, atoms are closely packed up. What is the liquids and gases? Here, atoms or molecules are not fixed and cannot form any shape and size. They gain the shape and size of the container. So, here atoms are loosely packed up. Now, what is the classification of the solids? Solids are classified into two categories. First is crystalline solids, second is amorphous solids. In crystalline solids, the solids in which atoms or molecules are arranged in a regular and orderly manner in three dimensions are called as crystalline solids. For example, metallic, gold, silver and aluminium. These are very good examples of the crystalline solids. And in non-metallic, diamond, silicon, quartz and graphite are very good examples of the crystalline solids. Now, what is the amorphous solid? The solids in which atoms or molecules are not arranged in regular and orderly manner in three dimensions are called as amorphous solids. So, for example, glass, plastic and rubber. Here, I have shown the image of the glass, silicon oxide, SiO2, which is the amorphous material. Now, see the structures of the crystalline, polycrystalline and amorphous. So, our idea will be cleared by seeing this image. In crystalline, all the atoms are arranged in regular manner in periodic fashion. In polycrystalline also regular manner, but in amorphous, the atoms are in irregular manner. Now, what is the differences between crystalline solid and amorphous solids? The first point is in crystalline solids, atoms or molecules have regular periodic arrangements. On the other hand, in amorphous solids, atoms or molecules are not arranged in a regular periodic manner. They have random arrangement. Second one, crystalline solids are anisotropic in nature, while amorphous solids are isotropic in nature. Crystalline solids exhibit directional properties, while amorphous solids do not exhibit directional properties. Crystalline solids have sharp melting points. On the other hand, amorphous solids do not possess sharp melting points. Here, crystal breaks along regular crystal planes and hence the crystal pieces have regular shape. For example, copper, silver, aluminum, etc. While in amorphous solids, they break into irregular shape due to lack of crystal plane, for example, glass, plastic, rubber, etc. Now, let us see the crystal structure. Crystal structure is the manner in which atoms, ions or molecules are specially arranged in crystals. Crystal structures are composed of set of atoms or bases, second lattice and third unit cell. What is the crystal lattice or space lattice? It is defined as three-dimensional array of points are specially arranged in specific pattern, or it is geometric arrangement of matters, that means atoms, ions or molecules. Characters of lattice. Let us study the characters of lattice. Now here, basis plus lattice equal to crystal. Schematically I have shown one flower as a basis and so many points in the lattice. So when we combine basis and lattice, then each flower combines with the lattice and we form the structure of the crystal. Now this is shown by means of atoms arrangement, basis plus lattice equal to crystal. So see here, this is the regular periodic arrangement of the atoms forming the crystal. Now, one typical example of home appliance here is given. The arrangement of the eggs in the tray is very regular arrangement, just like the crystals. Now, what is the unit cell? Here, the sky blue colored one structure is the unit cell. So, the unit cell is the smallest possible portion of or geometrical figure of crystal lattice, and which built up by the repetition in 3 dimensions is called as unit cell, or it is a fundamental elementary pattern. So, this unit cell is basic structural unit or building blocks of the crystal structure. Here I have shown the whole crystal structure, and this is just the basic building block of the complete crystal structure. So at the corner there are lattice points, and this complete 3-dimensional figure is one unit cell. Now let us study the characteristics of the unit cell. Now this unit cell is represented along the 3 crystallographic axes X, Y and Z, where A, B and C, these are the lattice constants, and the angles made by the 3 edges of the unit cells are alpha, beta and gamma. Now, what are the types of unit cells? Basically, there are 2 types of unit cells. Primitive lattice, we say P, and centered lattice, we say I. So, see the image of the primitive lattice. In this lattice, the unit cell consists of 8 corner atoms at the 8 corners. Now, what is the centered lattice? Again, there are 3 types of centered lattice: body-centered unit cell, face-centered unit cell, and end-centered unit cell. Now, this image shows the body-centered unit cell. So, already 8 atoms at the 8 corners of the unit cell, and this purple atom is at the exactly center of the body of the crystal. Then face-centered lattice. Here, all these 6 purple color atoms are at the center of each and every face. So, in all 6 faces of the cubes, so automatically 6 atoms at the centers of the faces. So, this structure is face-centered lattice, FCC structure. Then here, body-centered lattice. Now, in this lattice, along with the corner atoms, the base and opposite face will have center atoms. So, at the base there is one center atom, at the top there is one center atom. Now, this picture shows the simple cubic structure, body-centered cubic structure and face-centered cubic structure. So, here 8 atoms at the 8 corners. Here, along with the 8 atoms, center atom. Along with the 8 atoms, one center atom at each face. So, in all 6 face-centered atoms. Now, we have to study the elements of the crystal. So, see, these are the elements of the crystals. We say phase, age and solid angle. So this yellow color arrow indicates the phase of the crystal. This red color arrow indicates the age of the crystal. And this green color arrow indicates the solid angle made by the two edges of the crystal. Now, these three crystal elements form the mathematical relationship, and it is called as Euler's formula. Formula is F plus A is equal to E plus 2. Now, these are the schematic structures of the crystal lattice. Now see Euler's formula. Here F plus A equal to E plus 2. F means number of phases, A number of solid angles and E number of edges. Let us consider first tetrahedron. Phases are 4, solid angles 4 and edges are 6. So in formula this 4 plus 4 8 and this 6 comes here, 6 plus 2 8. The formula verifies 8 equal to 8. For the cube also the formula satisfies for octahedron and for dodecahedron. So done.